decided to do my term project on the slap shot in hockey because I've been highly active in hockey and I'm very interested in the biomechanics behind the shot. The slap shot is possibly the most popular shot in hockey. It is a shot taken by lifting the stick from the ice, pulling it backwards, and winding up, lastly bringing the stick forwards rapidly to shoot the puck. This shot in hockey produces more force and velocity than any other shot. Since there's a lot of force and velocity, it's great in a game because it can catch the goalie and players off guard. However, this shot also has very little accuracy compared to other shots. Now, over the next couple of minutes, I will explain the continuous steps that hockey players take when performing a slap shot. There are 6 phases to a slap shot. First stage is the backswing. This is the windup before the shot, and potential energy is built up here. The second stage is the downswing. This is the motion of swinging the stick downwards on the puck. During this, momentum and energy gets brought towards the puck on the stick. Thirdly, preloading. This is the bending of the hockey stick before the puck and the blade of the stick make contact. Fourth step is loading. This is the bending of the hockey stick when it makes contact with the puck. The momentum from the backswing and the swing forward provides a force to the puck. The fifth step is the release. This is when the hockey puck releases off the blade of the hockey stick. The force produced provides a large horizontal velocity onto the puck. The last step is the follow-through. This is the continuous motion of the hockey stick towards the target you're aiming for. Your hockey stick should end up in front of you. Now here's the 6 steps combined to show you the slap shot all together. As you can see, the steps have continuity and summation of joints. Since we all now know what a slap shot is, let's dig deeper into the biomechanics of it. There are many factors that contribute to the velocity of the puck during a shot. We've listed a few here. Puck impulse, initial and final stick velocity, stick stiffness, the composition, the amount of stick bending, and the force exerted by the player. However, when looking at the biomechanics of a slap shot, it's important to look at puck impulse. Puck impulse is a major factor that includes all the other factors within it. So the factors that influence puck impulse is the amount of time the stick is in contact with the puck will increase its final velocity. The contact time is increased by the amount of stick flex and the final amount of inertia. The rotation of the torso, shoulders, biceps, and forearms in sequence helps transfer momentum from greater moments of inertia to lesser ones. Another thing to note is the amount of stick bending is very noticeable. This occurs in the loading phase, which is initiated by the grand reaction force and downward pressure of the lower hand on the shaft of the hockey stick. The greater the amount of flex in the hockey stick, the more potential energy is built up and transferred into kinetic energy that allows the puck to propel straight into the net. Furthermore, the direct biomechanics involved with the slap shot are linear velocity, angular velocity, Newton's second law, impulse, center of mass, summation of joint moments, and continuity of joint moments. Hockey players want to generate as much linear velocity in their slap shot as they can, as this will result in an increased speed of their shot. Linear velocity is known as V equals WR, where R represents the radius and W represents the angular velocity. There's a direct relationship between the radius and the linear velocity, and also there's a relationship between the angular velocity and the linear velocity. Angular velocity is a change in angle over the change in time. Therefore, there is a direct relationship between the measurement of the angle between the stick and the ice and the angular velocity. An increase in this angle will result in an increase in angular velocity, which will increase the speed of the slap shot. As a player increases the height of their stick, they will increase the angle between the stick and the ice. As this angle increases, this will result in an increase in the angular velocity, which will result in an increase in the speed of the slap shot. Newton's second law states that force equals mass times acceleration. There is a direct relationship between the force applied to the object, the mass of the object, and the acceleration of an object. The greater the force applied to an object, the faster it accelerates. Therefore, the greater the force the player applies to the puck, the faster the puck will accelerate down the ice. Impulse has a direct relationship with force and time, as impulse equals force multiplied by time. An increase in time will result in an increase in impulse. Therefore, an increase in the amount of time the stick is in contact with the puck will in turn increase the impulse. Therefore, as a hockey player has increased time that the stick is in contact with the puck, the impulse will increase. As impulse increases, the momentum increases, which will result in the final velocity of the puck to be increased, ultimately resulting in an increased speed of the slap shot. In order for a hockey player to maintain stability during a slap shot, they need a bigger base of support and a lower center of mass. The bigger base of support, the more stable they will be. Therefore, they will have a wide stance with their feet spread apart. This wider stance will create a bigger base of support and will allow them to be more stable. Also, the lower the player is the center of mass, the more stable they will be. The hockey player should have their knees bent during the motion of a slap shot. This will allow them to be low to the ground, resulting in a lower center of mass. In order for the hockey player to stay balanced during a slap shot, their center of mass has to stay inside their base of support. The closer the center of mass to the base of support, the smaller the force required to push the center of mass outside of the base of support. A hockey player must use multiple joints when taking a slap shot to generate the most force. The more joints that are involved in a motion, the more force that will be generated. This biomechanic principle is very important because they are ultimately using their whole body. The player uses their upper body, torso, hips, and lower body, including knees and ankle joints, throughout this motion, as this generates the maximum force. The sublimation of these joint movements will ultimately generate maximal force, which will result in an increased speed of the shot. In order for a slap shot to generate maximal force, it has to be done in a coordinated, continuous manner. The motion of the slap shot should be continuous with regards to the joint movement, and the timing of the player's movements should be coordinated. Performing the slap shot in a coordinated manner will result in the greater force production, which will result in increased speed of the shot. As the player proceeds with the backswing phase, they should be using the joints of the upper body to generate force. As they move into the downswing, they should start to shift their weight from the back foot to the front foot, pushing the energy forward, allowing for maximal force production. During the weight transfer, the player will use the joints of the lower body, torso, and hips. The shift of the weight as the player is proceeding through the downswing phase will allow for a smooth, continuous motion. As the player is completing the preloading and loading phase of the shot, the weight is already shifted to the front foot. The player then releases the puck and finishes with a smooth follow-through motion. I hope you learned something about the biomechanics behind the hockey slap shot. Thank you.